Welcome to the third part of this tutorial. Now we will set up the Docker and Docker containers. So for setting up the Docker, make sure you have the source code account. You can run this convenient script to install Docker. So what Docker is, it's a virtual, it's kind of like a virtualization of operating system on your computer. So you can like run multiple Ubuntus. You can even run Windows on your Ubuntu. And these little things called Docker containers, they are already packaged with a bunch of installation stuff. So you have something called a Docker file, which contains a set of instructions for building the Docker image. A Docker image is a fixed image of operating system, and the Docker file basically maybe from like an existing image. Could be Ubuntu, could be Windows, could be anything else, and then it runs a bunch of commands. These are similar to the commands that we have run when we was doing the local setup. For example, you can see like the CUDA installation section is over here. Yeah. So now we want to install Docker Compose. So once you finish this Docker Compose section, you want to log in and log back out so that when you run Docker Compose, it doesn't force you to use sudo. Next, you want to install the Docker NVIDIA tools. This is a set of tools that will allow you to use the GPU inside the Docker containers. Okay, so apparently I needed a recent version of this. Let me just add the instructions here. Just give me a second. Okay, I have fixed the instructions. There was a versioning issue. Now if you run this, it will install the NVIDIA Docker tools. You want to restart Docker, and then you want to add this xhost thing in your bash RC. It's a little bit annoying because every time you open a new tab, you'll see this thing, but that's okay. So there's two ways you can set up the Docker. You can build locally. So there's Docker and Docker Compose. Docker Compose is like a composition of Docker things. For example, in this Docker Compose file, we have a couple services like simulator, friendly, and opponent. This builds the Docker image for the simulator, which can be located here, the Docker file. And this one friendly and opponent. Both of them refer to this here, which builds an image from this Docker file. So if you would just want to build one Docker file at a time, you can just do docker build dot in the same directory as the Docker file. And the issue here is because I probably need to I need to restart my system. I will come back when this is fixed. Hello, so I'm back. So to verify that Docker works, you can just do docker compose, and you can see that it's working. Going back to Docker, we have, as I can see, you can do docker build dot. As you can see, it's going to run these steps one by one. First, it's going to pull the image, and image is Ross Nordic, Ultra Soccer Nordic. If you go to dockerhub.com, or if you can also just go here, click on the Docker link. It will automatically link you to the Docker image. There's many other images like Ross Nordic. Yeah, these are just for example. Anyways, rather than building the entire image, I'm just gonna pull the image from the latest. We have a CI action that every time we've pushed to the master branch, it will build a Docker image automatically. And then instead of just building Docker image, you can just pull the latest Docker image to work with it. So for example, over here, docker compose pull, it will pull the two images, one for the simulation and one for the actual robot. So I'll just let this run for a bit, and this will take some time when it's pulling the images. As you can see, instead I've used Docker Compose. I just use Docker Pull because it gives me more information about what's happening when polling. If you want to know the name of the images, for example, in the simulator, you can see the image is called Ultra Robot Soccer webots, and for the robot itself, the image is Ultra Robot, just Soccerbot. Yeah, I'm just gonna let this pull. Okay, so once you see it's done, it will say download a new image for that. Yeah, one thing here, which you can see there are many Docker Compose files, but all of them are based on the main one. The main one basically runs the simulator and two robots, but one of them is disabled at the moment. The override keyword means that every time you run Docker Compose, it will always look for the override Docker Compose file, and over here it just exposes some network stuff, and you can see that our opponent is manually disabled. There's a bunch of test ones. These are used for the integration tests, which we'll cover later. There's also a game, the one docker compose.robot.yaml. This is the actual docker compose file that's run on the actual robot. As you can see, the image is :arm64, has a tag arm64 rather than the regular one. And the base image it's building from is from the arm64's image of Rust Noetic, because on the robot it is running not the 64-bit architecture that you have on regular computers. It's running ARM64, and that's why we need to specify when building the image for the robot that we're using specifically. This okay. Anyways, to basically run, you can do docker compose up. It is basically the same as running the local setup, except everything is in the Docker container. If you want to know the exact command that's run, for example, in friendly, you can see the command that is run. It's located here on commands. This is the entry point to the Docker container. Just a little information about some of this. Privilege means I have more access to the host computer. This is the build arguments used when you're building the Docker image. Adding ptrace and nice allows you to trace and nice inside the Docker container. Trace means using the debugger, and nice means lowering the CPU usage. PID host means it uses the PID system on your host computer. And this is a bunch of volumes. Volumes are like mounts. So because we are mounting the Docker container, the software on the robot into the Docker container, any changes on the robots in the code, that is Python, will reflect immediately in the Docker container. So you never need to build the Docker container again. You can just go into the file and then edit the strategy. You can like change the interval of something, and then test it with the Docker container. The only time you need to rebuild the image is when you have a new package. If you have a new package, or you have a C++ component that requires building, and for that you just need to do docker compose build, and then that will build all the images for you. Other things to note, let's see. Yeah, so there are also docker compose duo, which is 2 robots on the same team, friendly 1, friendly 2. Full, which is 4 robots on one team and 4 robots on the other team. I don't know if your computers can handle this much computation. Game controller is just starts the game controller, which is this. This is the game controller. Let me just quickly show you through webots a little bit. So you can pause the simulation by pressing that. You can step the simulation one by one here. You can open up here, and then you can get the location of the get the location of robots as defined here. See the translation and rotation. Location of the ball. These are ground truth values. And can move this camera out of the way, and you can zoom in. Press shift. Oh, sorry. Press. I think. Yeah. Press control to pan, and then you can go in and like see what's going on. It was the robot. I'll go back to running. You can see this is Ultra 1 versus Ultra 2. There are 5 strategy states: initial, ready, set, playing, and finish. So in the beginning it starts with initial, goes to ready, set, and playing. If you read the strategy code a little bit, you understand. And this is the countdown timer. Basically here you can see the robots, the number of red, yellow, and blue cards it has. I've never used any of this, but that's something to care about in the future. Oh, I did a kick. That's kind of strange. So if you draw the robot, the behavior should automatically allow the robot to get back up to standing position. What else have I not mentioned here? Yeah, so you can also shift to move the robot around. Use these rotating guys to also rotate the robot, and shift and such. And you can do that for the ball as well. Shift to bring it over here, and keeps on the 2D plane. And if you put it in front of the robot, it will look for the ball, and it will go to the ball. I think that's it about the simulation and Docker. We're gonna stop here. Actually, one more thing. You can open rviz, and you go File, Recent Configs, and select the rviz file here. This is the rviz. It's a very useful tool. It allows you to know where the robot thinks it is. You can see where the field lines it's looking at, what it's seeing on the screen. And how this works is you can turn on and off things you want to see. For example, I don't want to see the map. I can turn that off. Right now it's stuck to the 2D view here. You can change that to orbit, allowing you to see the estimated information about the robot. If you don't want to see the robot model, you can look at the TF frames. You can select these on and off, and all of this is under friendly 1. Friendly 2, friendly 3 are the other robots. TF tree, so if you ever need help with the transformation, for example, I want to find the camera position, you can find it here. But this is all odometric estimates of the location and the relative position. One quick thing about the TF tree. Another tool that will be useful for you is to use RQT, and go here, visualization, TF tree. If you ever have an issue with a TF kind of issue, you can look here. It shows the basic transformations world to ODOM and what nodes are doing that, and the different frames and links. If you have some issue or the robot doesn't show up, you'll probably see some link missing over here. I guess while we're at it, I think that's it for the simulation in Docker. In the next video, I'll explain some things about the testing and such.